Welcome to the YouTube channel PCMB Tutorials. Today we are going to learn Class 9th Physics Chapter Heat Part 9. So, in this part, we are going to learn about the new topic of this chapter. Previous part, we have learned till the factors affecting alpha. Today, we'll see negative coefficient of expansion. Negative coefficient of expansion. Certain substances expand on cooling and contract on heating. Such substances have negative coefficient of expansion. Example, water. 0 to 4 degree, between 0 to 4 degree Celsius, cast iron, rubber, etc. Why does rubber contract on heating? Atoms in a solid vibrate horizontally as well as vertically. Longitudinal vibrations increase the average distances of atomic separation, whereas transverse vibration have just the opposite effect. If the atoms of a solid have greater displacement of longitudinal vibration, it expands. If the displacement of transverse vibration is more, the result is contraction. In rubber, transverse vibration dominate the longitudinal vibrations due to interlinked chains of atoms. Hence, rubber contracts on heating. A bottle and its stopper are made of substances A and B respectively. The stopper is stuck in the bottle's neck. How will you remove it? If coefficient of A is negative and that of B is positive. A by heating, B by cooling, C stopper cannot be removed. So the answer is the stopper can be removed if a gap is formed between the stopper and the inner wall of the bottle neck. For the gap to be created, either the bottle's neck should expand or the stopper should contract, or both should happen simultaneously. If we cool the bottle, the neck expands as it has negative coefficient of expansion, and the stopper contracts on cooling as it has positive coefficient of expansion. So the solution is cooling the bottle. Now we're going to learn Harrison's compensated grid iron pendulum. Harrison's compensated grid iron pendulum. It consists of 5 iron bars and 4 brass bars connected to each other. The iron bars can move freely in an upward direction and the brass bars can move freely in downward direction. The ratio of the lengths of iron bars to brass bars is 3 is to 2 because the coefficient of linear expansion of iron and brass are 2 is to 3 ratio. Thus, 1 degree Celsius rise or fall of temperature, the expansion or contraction of iron is counterbalanced by brass. Thus, the effective length of the pendulum remains same and hence the clock gives correct time. Thus, we see that thermal expansion of solids is used in a number of devices. The increase in length of iron rods is compensated by the increase in length of a brass rod. First iron rod, B brass rod. Now applications of thermal expansion. So we know that solids expand on heating and contract on cooling. The extent to which a solid expands or contracts depends on its coefficient of expansion. What happens if we obstruct the free movement of solids while expanding or contracting? A very large force is set up in them which may bend, deform, or break the solid. This principle is used in many constructive devices. Let us know some of the applications of thermal expansion of solids. First, iron rims of chart wheels. The wooden wheels of, I'll write, iron rims of chart wheels, iron rims of chart wheels, the wooden wheels of a cart wheels. The wooden wheels of a cart are fitted with iron rims. The iron rim is slightly smaller in diameter than the wheel. The rim is heated and allowed to expand till it is larger than the wheel. Then it is slipped into the wheel. It is allowed to cool the rim and the rim contracts, tightening over the wheel. Second is riveting. Riveting. This is a process of joining two metal plates with small cylindrical steel rivets. Holes are drilled in the plates to be joined. A rivet whose length is less than the total thickness of the plate is taken and heated till red hot. When the rivet expands, it is slipped into the hole and hammered to flatten the ends. When the rivet cools, it contracts and holds the plates together firmly. These kinds of joints are waterproof and steam-proof. Hence, this process is mainly used in making boilers for ships and locomotives. Third, bimetallic strips. Two strips of different materials but of equal lengths are riveted together at a number of points such that they do not slip sideways when